this use of these words, we're taking a monomial, a single term, and multiplying it by a polynomial. And we're using polynomial as maybe it's a monomial times a monomial. Maybe it's a monomial times a binomial. Maybe it's a monomial times a trinomial. Right? We're using polynomial here to describe all of them, right? So, monomial, single term, monomial times either a monomial, binomial, trinomial, polynomial. We're going to say polynomial just in all-encompassing definition. So, we are going to use the rule or rules for multiplying powers. We're going to use the rules for multiplying powers. We're using the properties of powers. So when we do this, those rules are multiply the coefficients and add the exponents. Multiply the coefficients, add the exponents. I mean, and again, let's practice. I mean, it's pretty straightforward. So let's just do some extras. Some extra added practice. Example number 1. If I had 4x squared times 8xy to the 4th, it's a monomial times a monomial, correct? I'll write this over here. If I wanted to get even more specific, I could say that this is a quadratic monomial, because the exponent is 2. Times a quintic, 1 plus 4 is 5, quintic monomial. But we're not naming them, we're not classifying tonight, we're just multiplying. But multiply the coefficients, add the exponents, right? 4 times 8 is x squared, and x to the first make x to the third, y to the 4th. That's it. That's a monomial times a monomial. Because that y has to come along with it, right? It doesn't disappear. Because that's an x and not a y. You have to only combine, right? And if I wanted to, name this, just for some extra practice, this would be a 7th degree monomial. Because you have in one term, this is one term. In a term, you add the exponents together. 3 plus 4 would make it 7th degree.
Throughout the class, are we going to learn how to multiply other types of monomials?
Miss Long, why is a monomial not called a
Uninomial?
It's like a monomial?
I don't know.
Monomial.
All right, so let's try this one. 10x squared times negative 3x minus 2. So this is a monomial times a binomial, right? Now again, this classification part is just a little extra practice. In fact, it's a quadratic monomial, exponent of 2, times a linear binomial, because the exponent's 1. How would you solve this problem? What would you have to do?
Distribute.
Yeah, you'd take the outside and distribute
Bang.
inside. You just do the distributive property. Like, don't freak out just because there are variables there, right? Multiply your coefficients. What's 10 times negative 3? What's x squared times x? X to the third. And then 10x squared, right, times negative 2 this time. So 10 times negative 2, x squared. Because that x squared travels along with it, right? If you need to write it out, 10x squared times negative 3x and 10x squared times negative 2 in the beginning, go for it. If, good, it's a cubic, because the highest exponent is 3. Do not add 2 and 3 together because they're not in the same term. A cubic binomial.
Binomial.
All right, let's try another one.
Monomial.
3x squared times 4xy to the third times negative 2xy plus 3. I don't know. Again, sometimes I'm making these up and we end up with a lot of the same types of problems. This would be, if I was going to classify it, a monomial times a monomial times a binomial. I'm still going to get, I still have the skills to do all of this. Now, one of the overwhelming parts might be like, oh, Mrs. Long, order of operations, I need to do this first, but can you do this first? No. So we're just going to start simplifying. So out here, I'll combine, what's 3 times 4?
12.
What's x squared times x to the first? X cubed times. And y to the third just tracks along. Because you have this monomial times this monomial, right? 3 times 4, 12. X squared, x to the first makes x to the third. Y to the third. Oops. Make that a 3. Then I can take this single monomial, right? Because I had 2 monomials and I multiplied them together to get 1 monomial. I can now take this outside monomial and distribute it across the parentheses. 12 times negative 2 is negative 24. X to the third and x to the first makes x to the fourth. Y to the third and y to the first make y to the third. Nope. Fourth.
That's what I thought.
Then 12 times 3 is positive 36. X to the third, y to the third. If I was going to name this, what would it be?
Wait for me to write
A
them.
quadric binomial.
Eighth degree. Why eighth degree and not quartic?
Oh,
The
Together, right?
8
They're in the same term, so I add them together.
would be an 8th degree binomial.
I know we're taking notes. So again, embrace the nerdiness of it. It's kind of cool that we can do this. Let's do a trinomial just so that we have an extra one.
What's that point?
All right, so let's do negative 3x to the fourth times 8xy to the third negative 2xy to the third plus 7x squared y minus 10. Woo!
do I need to out of breath for this?
I love it. You might need 2 desks, Taylor.
Taylor writes too big.
Why don't you just do it in your notebook?
So, outside, simplify, then we'll distribute, right?
Okay.
Monomial times a trinomial, yes? Mono times mono times tri. Quartic, quartic. Ooh, they're all quartics, guys. Oh, look at that.
Quartic always pops up.
All right, here we go.
All of our problems.
Negative 3 times 8 is negative 24. X to the fourth and x to the first, x to the fifth, y to the third. Yes? Okay. Negative 2x, y to the third, 7x squared, y minus 10. Then, boop, boop, boop.
Let's rock about that 58.
Negative 24 times negative 2 is positive 48. X to the fifth, x to the first, x to the sixth, y to the third makes y to the sixth. Negative 24 times 7. Oh, I didn't realize I went this big with numbers. 8, carry the 2, 148, negative. X squared, x to the...
You forgot a 20 in that.
I forgot a 20 in it? 68, got it. X to the 7th. You're right, I did forget to carry my 2.
Man.
Y to the 4th.
Oh, yeah.
Then, positive 240, x to the 5th, y to the 3rd.
This is a big.
It's beautiful!